What if I told you you could build and fly your own drone like this, even if you have never touched one before? No shouldering, no confusing tech terms, just step-by-step guidance to go from unboxing to flight. In this course, you will build a pro-grade F450 drone with Pixhawk 2.4.8. No experience is needed. Configure it easily with Mission Planner, and I will show you how you do that. And master flight modes like alt mode, stabilize, land mode, and even autonomous flight. Whether you are a hobbyist, student, or just curious, this is your shortcut to drone mystery. Ready to take off? Well, now, and let's build your first drone. See the thing stuck there? This is something you can build with me. Drone is the latest technology. Actually the trendiest technology. You should build a thing like that you'd be able to maneuver, you'd be able to control, you could be able to fly anywhere. The reason why you should build drone, the first reason is you could do exploration. Tons of different places you could do exploration. You need drones. You could do surveillance, great military surveillance. Even you could do drone for food delivery application, delivery system. Big companies started to do that. So you should do that as well. It's the time to do that. And then, of course, at the end, there is a military application, and that is unlimited. With the drone, the possibility is limitless. So this is the course that will teach you how to start the basics. And once you master the basics, you can go from here to very far. Limitless. I strongly suggest you to take this course and learn the most basics, fly like this, and go to the next step and be a professional. So let's take more look on this thing. So now what I'm going to do, as you saw some maneuvers that I have done with the drone, right? I've done that. But now you'll see that I'll ask it to come back in a sense that RTL. So it will come back to its flying position automatically. So we should go ahead and do that, right? So here, I'm going to click on this. All right? So it's gonna go up. And then slowly it will come down the place where it started off. So as you can see, the drone is up in the sky. Okay? Let me take one over. So now this is the place. This is where it's going to land. Okay, as you see, it's landing. So the landing is amazing, isn't it? It's going to land on its own, and I'm doing nothing. You see that? I'm doing nothing. This is something that you want to build and use a drone.
So let's learn about the course first. So this course would be about Pixhawk hardware, which means this is the flight controller we'll be using to fly our drone. And one amazing thing about this course is that you don't need any shouldering. No shouldering is needed. And I know this could be a little scary and a little bit difficult for a lot of people. So we don't have to do any shouldering at all. So let's continue. Now about the course, so definitely it's hands-on learning. So everything is practical over here, from this frame that is F450, Pixhawk hardware, FlySky system, which is our transmitter, and ESC. Everything would be practical, so don't worry. Now every setup is very professional. We're gonna use Mission Planner, this software, which is a very professional software. It's used in commercial places, so we're gonna use that software, and it's totally free. Don't worry. We use this software to calibrate different kind of sensors, tune the parameters, and set up our flight mode and everything. Okay, all right. And another thing, beginners they struggle about flight, which means how to fly. So I'll give you some practical examples how to fly slowly for beginners, and I'll also show you how to turn off GPS so that you can try any kind of confined environment. Like you don't have to go out and find a big place. In small place we can also fly that. Now let's see what you will learn in this course. Well, definitely the drone assembly. So we're gonna assemble everything, all the hardwares together, which I've already said, and the configuration would be there using Mission Planner and FlySky transmitter. And we'll cover various flight modes like stabilize mode, alt hold mode, landing mode, and we'll also try to see pause hold position. Okay, so there are different positions. At the same time, at the end, very end, we'll also try loiter mode, so it'd be there. And then along the way as we work, we'll also see some troubleshooting, that what to set up and what not to set up, and if the drone behaves strangely, how to fix that. We're gonna also see that one, and we'll also give tips for that. Definitely you will have a lot of tips for safe flying and how to start for absolute beginners. Definitely I'm gonna cover step by step, don't worry. And at the end we'll also focus on how to understand the components and why we need that, and we'll do many things, and I'll also say why you do that. But at the same time, because sometimes I may cover some theory, so you can feel free to skip those sections, because I'll say in each section which to skip, which not to skip. And why this course? One thing, once again, I said at the beginning, so it's no shouldering, no stress, so you don't have to spend extra money on it, so take it easy. And it's totally beginners friendly, because when I started I struggled a lot. I learned everything by myself, and it took me actually months. So if you follow me, actually in 2 hours you'll see that you're almost mastering everything if you're able to follow it. So my months of experience here I'm gonna compile in 2 hours. So that's the thing that you will see over here. And eventually everything is practical, because the way we are going to build this drone and the hardware we are going to use, it's already in commercial phase, so it's practical. And if you're able to follow this course, actually you'd be able to fly and carry things with the drone. Okay, and we'll also see that how to set up different spots so that the drone can fly from one place to another place automatically. So pretty much a lot of the things, those practical things and commercial things would be covered. So what you'll need in this course, definitely you'd need this Pixhawk 2.4.8 flight controller, a quadcopter frame that is F450, FlySky transmitter and receiver, ESC motors and ESCs, and a computer that can install mission planner. Definitely you can use Windows 10 or Windows 11 or above, and there are some other hardwares you can find from the listing below later. So take it easy, at least you have to have all this, then you are good to go. So definitely this would be a course that you'll enjoy and learn a lot if you have never built a drone, or you're struggling to build a drone, and if you have never built a commercial drone. So this would be pretty much close to commercial drone. You'd be able to show it to a presentation, to a course defense, or to a thesis. So many things you'd be able to do that. Let's continue and make sure you enroll in this course. These are the equipments or parts or the devices that you need to build this drone. So over here, these are all part of frame. So we are building F450 quadcopter. So this is also called F450 frame. Okay. Now in general, all of these things, they should come together. Now if you don't know, these are also the two plates, okay, where we are going to attach these arms, and below it we are going to attach these legs. Okay, so in general they're all together, they should be all part of one package. So that's the first thing. All right, so the next I want to see this ESC. Now these are some very good ESCs, as you can see that. So it's a BL Heli. So these are very standard and very durable ESCs that you should go ahead and buy. But of course there are cheaper one, but I suggest that you go ahead and buy a good one, okay, so that you can use for a long time. So you have to know this one. All right, so there are other brands, cheaper brands. And then over here, this is a power splitter, as you can see that, because we'll have 4 ESCs, so we need to distribute power to the ESCs. Okay, and these are T-plug ESCs, as you can see that. Okay, so make sure that you get the right one. All right, and then after that we have this motors over here. Now these motors are XXD motors, as you should see that. Okay, I have 4 of them, but there are better motors as well, so you could buy them if you want. And one thing that you'll see that over here, it says that 1000 kb. Now what does it mean? This requires a lot of explanation, so you should, if you want to follow along with me, you should buy this 1000 kb as well. Okay, so that's very important to know. So I'm going to explain this meaning later, but there are also better version of this motors. Go ahead and buy 4 of them. All right, and then another thing, if you want to follow along with me and you don't want to do any kind of shouldering, make sure that they're bullet headed. These are called bullet headed, which will attach with this ESC. So you're just gonna plug in and you're good to go. Okay, so go and get 4 of them, but there are of course a better version of them. So that one. And now over here we see our battery. This is a LiPo battery. Now this battery is 5200 milliamp, and it is 3S. So as you can see that there are 3 batteries together. So there are 3 batteries together. And then the one that I bought, that is a 35C discharge. You could also go ahead with 30C. Now the battery itself, you don't have to buy 5200 milliamp, because that could be a little bit expensive. If you're just trying to check out how to build drones, you could go ahead with something like 2200 milliamp and 30C. That also works. Okay, so get a good one. All right, so battery is very important. All right, so these are the basic hardwares. Now then there's copter, or the flight controller, and the brain. So this is where it comes in. Okay, so in our case we are going to use a Pixhawk. So this is my Pixhawk. As you can see, it may look a little old and rusty because I have a lot of Pixhawks. I was using them. So this is from one of the old copters I'm using, so but it's okay. You definitely, for your case, most probably it's a new one. Okay, so this is the brain controller, or I would say flight controller. You can also say the brain of the whole drone. Okay, all right, and after that with this you will have this kind of hardware safety button, all right, and this is also the buzzer, and then also this hardware, this is a power module, so this is going to give us clean power to our drone. So in general, these few things, they all come in one package. You can buy them, but if you do want, you can buy them separately, and it's totally fine, because I also do them. I also buy them separately. These 4 things you could buy. So as you can see that this is also T-plug over here, so make sure that all the power related things, they're all T-plug. All right, so that's all about our hardware, about our brain controller or flight controller. I sometimes call it brain controller because it controls everything. Now this one over here, you'll see that this is the receiver and this is the transmitter. Okay, in general they all come in one package as well. When you buy a receiver, when you buy a transmitter, you should buy the receiver as well. You just don't buy the transmitter. And in my case, I'm using FlySky transmitter, so this is also FlySky receiver, and then I'm using, this is FSIA 6B, so go ahead. So it might have a few ports, like 6 channels, actually 6 channels, as you can see over here. Okay, and then of course this is a receiver. I'm gonna use this mode 2 receiver, which means that left stick is our throttle stick, so this would be our throttle stick. Okay, so this is the one that we're going to use for vertical and downward movement. All right, and this is for left and right, back and forth. All right, anyway, so that's all about a receiver. And after that, here I also have this GPS module. You should have one. This is not must to follow this thing. It's better if you have, you'd learn a lot more. Okay, I suggest you to have one, but if you don't have, it's good, you're okay. All right, so that's about our GPS module. All right, and then these are some handles that we could use to tighten the screw. There are different kinds of screws. They all come in package. Whatever you buy, there should be always the right screw, so don't worry about that one. So, and the last part that we need is the propellers. Now my propellers are quite old because I do a lot of tests, so a lot of them, they crash, they hit things. Okay, these I do a lot of tests with the drones, so in your case definitely there would be new propellers. The one thing about the propellers is that they would be like 1045, okay, 1045 propellers, which goes with this kind of quadcopter, that is F450, and at the same time, these propellers, they go ahead with this motors that says 1000 kb. Okay, if you have 1000 kb, your propeller should have this mark, something called 1045, something like that. Okay, so make sure that you buy the right propellers, because if you buy too big or too small, you're gonna have a hard time flying the drone. So buy the right one. You can also check it from the spec. So now if we have everything ready, so we can go ahead and start working on this.
So let's get started. So we're going to download Mission Planner. So I'm going to use Bing, and over here I'm going to write Mission Planner. Okay, right. Now over here, let's go ahead and click on this Mission Planner. So it's going to take you to this ardupilot.org planner. And then here we see it already says that latest Mission Planner installer from here. Now it could be hidden. If you come here first time, it could be hidden. Okay, so you might have to click on this. Okay, and then it will open up. And then you're going to click on this so that it goes ahead and download. I've already done it, so I don't need to download it anymore. Okay, right. Now over here, I'm going to go ahead and double click, and it says preparing to install. So you might have to wait a few seconds. And after that, it's going to pop up a window like this, and we're going to say next, and let's go ahead and agree with the license. It's all very simple steps. Now, if you're doing it first time, you will see that a lot of the windows, they pop up, and you have to say yes. Okay, black CMD or terminal, which is going to pop up soon, so don't get scared. In general, it's pretty fast. It may take the whole installation 1 to 2 minutes if your computer is good. So we are progressing. Hold on there. Okay, so we have seen a few windows that pop up, and it's pretty normal, so take it easy. And after that, here it says that install the driver. So we're going to go ahead and click install. So it's going to install the most important drivers that we need. Like these are the drivers that we need, and make sure they're all installed. And if you somehow missing some of them, it could be bad and it could throw error in future. So make sure your installation installs everything. Let's go ahead and click finish, and then I'm going to say launch mission planner, and then over here it's going to go ahead and launch the mission planner. And once again, over here you may get stuck for a few seconds, even 2 minutes, depending on your computer configuration, and it's going to launch this application mission planner from this terminal. That means that it's also going to show a lot of loggings, so you have to wait for that. Okay, all right, so hopefully everything is working and it's still not dying yet. It does look strange at first time. Now over here we see that mission planner has been launched. Okay, all right, so this is our default configuration. Nothing is connected over here and everything is 0, so that means everything is working fine. Okay, so if you see this small, you can enlarge it by dragging it like this. I like to make it bigger like this pretty much, because it will have a lot of information. Anyway, so that's the first step about mission planner installation. Okay, so now since the installation of mission planner is done, next section we're going to take a look at Pixhawk and what is Pixhawk and what it can do. Okay, so in this section we are going to see what is Pixhawk and what it can do. Now here I have this image, and over here this hardware, as you can see that it's written as Pixhawk already. Okay, so this should be our Pixhawk. Okay, now Pixhawk is a complex hardware, but yet lightweight and very powerful. Now this Pixhawk hardware, this one, it is the brain, brain of a drone or any kind of vehicle. You can think like that. So if you have this Pixhawk, you'd be able to fly your drone, machine, or your plane or vehicle, whatever you say. What Pixhawk does is all of this different kind of hardwares, as you can see that, it all bring together. So without Pixhawk, these are all useless. You cannot do anything. Now Pixhawk is also called a flight controller. That means it controls your flight. Okay, so it's the brain. It controls the flight. For example, how fast it should go, where it should go, and the orientation, rotation, velocity, height, everything is controlled from here. Okay, so that's why it's called flight controller, and it's also the brain. Now over here, as you see that the very first hardware is connected is the buzzer. Okay, so it makes sound. So for some events, Pixhawk may send a sound and it plays it. So Pixhawk of course needs external hardware. Like here we do see a switch. Now we have to click on this switch to start flying. Before we fly, we have to switch on it, and then it would be in arm mode. Arm mode means that it's ready to fly. Okay, now here there are other hardware, telemetry information. These are, for example, different kind of sensors they can connect with this. So there could be sensor, like this is a sensor. So different sensors they can connect with this. Like one of the common sensors, that the sensor that we are going to use in our application, in our course, is this GPS, this kind of GPS. So GPS should be connected here. So GPS is also like a sensor. So all of these things, they are all connected because of this Pixhawk. Now another common thing that we'll be using and seeing a lot is this receiver, because this is a receiver and this is a transmitter. Okay, so this is like the remote control. So it's going to send signal to this receiver, and as you see that this receiver would be connected here as well. Okay, so as you see that you need different kind of hardwares to fly a drone or fly a vehicle. You connect all these hardwares pretty much with your Pixhawk. Now at the top we do see some motors, as you can see that. Now of course the motors, they are not going to directly control or connected, actually directly connected with our Pixhawk. They are not going to directly connect with our Pixhawk. In between we'll have other hardwares. These are called ESC.
electronic speed controller. Now this speed controllers, like if you have 4 motors, you'll have 4 speed controllers, and 4 of them should come over here. As you can see that they are marked. Okay, they are marked here. So ESC, they would be connected with your Pixhawk, and then each ESC will have a motor. Then of course we'll have a battery, LiPo battery. Okay, so LiPo battery somehow is also connected with this Pixhawk. So as you can see that Pixhawk is the brain. Not only the brain, it glues everything together. Whatever external hardware you have, pretty much all of them would be connected with this Pixhawk. Okay, now in our application, this motors, this ESCs, this frame plate, this LiPo, this Pixhawk, this buzzer, this GPS, the receiver, all of them we are going to use. Okay, so after seeing this, you'll have an idea what is Pixhawk and how it works. So let's continue.
Okay, now since we know about Pixhawk, so we're gonna continue to work on this, and we are going to start hardware wiring, which means we're gonna have Pixhawk, buzzer, and a switch, and then we are going to connect them.
Okay, so here we go. Here we have our Pixhawk. Make sure there is 2.4.2, and then we have this buzzer, and after that here we'll have this safety button, failsafe button, and then we also have this GPS. Okay, so make sure that you have the correct hardware, and the very first thing we are going to do, we're going to take this buzzer over here, this one, and then we are going to put it here, right here where it says buzzer. Okay, so let's go ahead and do that. Okay, I'm done with this. All right, and then over here I'm gonna take this safety button, and then here it says switch. Okay, so let's go ahead and put it here. Okay, right, so I'm done with this too. The next one is this GPS module. Now over here you will see that it has kind of 2 ports over here, or came out 2 ways, so that you can plug into 2 different ports. Okay, so this one is going to go for over here where it says that I2C. Okay, so let's go ahead and do that. And then this one, obviously here it's marked as GPS, so we're gonna do it for GPS. Okay, so now with this, the basic setup is done. It's a very basic setup, but whether it is done or not over here, we can verify it. So how to verify it? I'm gonna take a USB cable. Okay, so this one over here, and I'm gonna plug this USB cable over here. Okay, then I'm gonna connect it to my computer.
Oh, so I have this USB cable. Okay, so I'm going to connect this. So I'm going to put it here first, inside this. Okay, plug it in, and then over here I'm going to connect with my Windows, and then the lights are blinking, and if the connection is successful, it will also make a sound. So you heard the sound. So when you heard that beep beep sound that comes with a nice beautiful tone, that means that it is successful. So I'm gonna disconnect again and let you hear the sound. Okay, so I'm going to disconnect it from here, not that one, that's from my Windows. So I'm gonna connect it one more time. Okay, so light is blinking, and now the sound would come. So let's hear for it. Okay, this is the sound I'm talking about. Okay, so that's the sound we need. That means that it's connected with your computer. So that's what it means. That means it's well connected, the whole system over here, because the buzzer was making noise. So that means that's a great thing. All right, so make sure this is lighting. All right, so it has not much to do with now. We'll see that how it works in future. Okay, all right, so the next thing we should see over here. Okay? All right, so the next thing we should see over here, you should select your port. Okay, so in my case, I'm with Windows COM4. For a lot of you, it might be COM3, so you have to know which one. And sometimes this port is not enabled, so you have to go ahead and enable it. All right, so select this. In general, the one that connects has com, that means that's the one that you should go ahead and connect. Okay, so let's go ahead and click on this. All right, and then over here you need to go ahead and click connect, this button, and you'll see something like this. Okay, and it changed great. And at the same time over here you will see that it says disconnect. So that means if you click on it, it will disconnect. Okay, and it will reconnect. All right, so it's connecting with Mavlink. So now that's what we have, and you should also have the same thing. And over here you should have similar output. Now, depending on the version, a little bit different. Here you might see different messages. Right now we are not connected with any battery, so that's why we see this thing is basically the battery input and output range. Okay, all right, and not ready to arm, that means we are not ready to fly. So that's what you have to mean, you have to understand. And then GPS no fix, that means the GPS is not connected, and of course the battery information, everything is 0 because we are not connected with 0. But then we are not connected with battery. And then also disarmed safe, which means it's in disarmed situation. That means that it's not ready to fly, and it's disarmed, not flying state, which means it's very safe. All right, and then over here it should be this thing over here. If you move it, okay, you'll already see that it starts to show you the orientation of your device. So the place where I am right now, it might not be completely flat. Okay, so that's why it is showing you like this. So this position is completely flat for me. In general, most of the time when you put it on a flat surface, it should be flat. Okay, and we always have to make sure before we fly, it is always like that. It has to be flat like this. Okay, all right. Okay, so now anyway, so that's the basic UI understanding. I mean, basic understanding from the UI, that this information, what it means. And then also we see that this is your information. So for now, it could be any random values for you guys. How you put it doesn't matter. As you rotate, you will see that this changes the value. Okay, in different direction. In general, you have to move it together with the campus, all right, or the GPS. Okay, all right. So a lot of the things will change, especially this one, this value. As you can see that this value will change. A lot of other value will also change. But of course, in coming tutorials, we'll see how to set up these things, and that's why we are going to learn over here, and we are learning. Okay, so this is a lesson that you can skip. You don't have to learn it, but I suggest you to learn because this can help you a lot in the future. Okay, now the thing that I'm going to explain or talk a little bit in this session is about this message section over here, the one that you see. Okay, now when you boot up or connect your Pixhawk with this mission planner, you will see a lot of logs that comes here in messages section, and this might be very useful. A lot of the messages, like I already have here. Okay, so a lot of the messages that we see, they are here, and these messages are very useful. So every time you have things go wrong, you can definitely see and come over here. But at the beginning, they might not make a lot of sense. But here I'm going to explain a few things very quickly, because the actual log reading and understanding, we'll see that later. So anyway, so when you first time connect, you'll see the information over here. So few of the information could be quite important. So one of the information that I want to take a look at this one. So most probably you'll also have this one, but if you don't see messages like that, that's okay. So that's why I said that you can skip this. It's not very important. So anyway, so this one here, it says that Chibi OS, which means that actually it's an operating system, because our Pixhawk, the hardware, the board that you bought, actually it's a small computer. You can think like that. Okay, so it also needs an operating system. Okay, so it's an operating system. This could be the version number. And then here you see that Ardocopter, actually this is the flight controller software itself. So this is the software that connects with our operating system, and of course operating system talks with the hardware. Most operating systems directly talk with the hardware. So Anyway, so this is the brain, okay, and this is version 4.1.0, and this is a very stable version. A lot of time when you work with Pixhawk 2.4.8, so this is the version that you will have, okay. And the other thing that I want to talk about is this one, okay, FMUV3. F means flight, M means management, U means unit, V means versions, okay. So this is a flight management unit version. So all it does, actually, it handles some drivers, okay. So drivers, hardware drivers like barometer, compass, powers. So all the hardware related drivers, the specification is done over here, and how they handle input and output. So a lot of them are from here, okay. So in general, also when you work with Pixhawk, so FUMV version, so that's 3 should be installed in Pixhawk 2.4.8. So if you're using Pixhawk 2.4.8, so this is the firmware version that you should use, okay. So you can think of like a hardware management unit, which helps you to, I mean, these are driver specific information that directly has to do with the hardware itself, okay. So anyway, next time when you gonna build something, install something, I mean install the firmware, it has to be this one, okay. So anyway, in our next section we'll see how to install the firmware. All right, so in this section we are going to install the firmware. To install the firmware, very first thing you have to do, you have to disconnect this one. So let's click disconnect and physically disconnect the USB, okay. That's what you have to do. Make sure that you always do that. And then here you have to come to this setup section, and then here you will have this install firmware, okay. So go ahead and click on this. All right, and then this is the time you can connect with your Pixhawk. All right, and then over here we are going to use this copter, okay. So this one, because this is the one that we are going to build. So you're gonna click on this, and then you'll see a pop-up like this. And do you want to upload this? We'll say yes, and then over here it's gonna let us choose the platform. So this is the one that we are going to choose, okay. This is the one, and this is what I was talking about early. So this is the one that always goes with Pixhawk 2.4.8. all right. And then this actual firmware for this one, so this is the version name, you can think like that, and the actual software is this one, the firmware itself. So this is the one that we are going to upload. So let's go ahead and click upload. Now here it will start to do this, and it will download from the internet, and I think would be done very soon. So it's going to erase the earlier stuff that I had early, so we need to wait. Well, now it's programming and it's going pretty fast. All right, so here it says that upload done, okay. Well, that's very good. Now I'm going to now over here you heard the new sound, okay. All right, so that means that it's connected, the firmware itself is now connected with our operating system. I'm talking about mission planner actually. And then make sure the port is correct one, and then here you can select connect, okay. All right. Okay, so this is something that a lot of time the beginners they get scared of, but we just install the firmware and it's as easy as that one. So now let's come over here to the data section, and here we still see a lot of problems, but right now if you come over here you'll see that these are the information that we see popped up from our newly installed firmware. Okay, so this is the firmware. As you can see, that is the one that we have installed, and Ardocopter. So here is 4.6.2, but earlier I was talking about 4.6.1. So this is even better version, most probably the latest stable version. Okay, all right. And then here we also see that U blocks, which is actually our GPS. Okay, so this is the GPS hardware that's connected already. Okay, and then there would be a lot of other issues, so we're going to take care of them one by one. So we'll continue in next section. Okay, so one thing here we see that over here we have an error where it says the check frame, and basically it's a check frame error, and it is asking you over here, as you can see, that check frame class and type is asking you to check. Now pre-arm means that before we fly, we need to check this thing. So these are called a pre-arm check. Okay, so you have to know that. Now this is where we need to check, but a lot of you might not have this issue. Okay, so if you have this error, you have to follow me. A lot of you might not have this issue. So whether you have this issue or not, here you can see, or even you can check the log from here. Okay, all right, so if you don't have this issue, you can skip, but there are things that we can learn here. I'm going to show you, which would be very, very useful. So now to solve this issue, okay, first I'm going to address why this issue. In the older version of Mission Planner, you might not have this issue. The new version, and as well as the new Ardocopter version, which is 4.6.2, they have this issue. Okay, in 4.6.1, I don't think they have this issue. So the issue is that this Mission Planner doesn't recognize the copter. Like, we have 4 motors, so it doesn't recognize this thing that our drone or robot will have 4 motors. Okay, so it doesn't recognize it automatically, but no problem, there is an easy fix. So all you need to do, come here, config. Okay, and over here we have list of parameters, and these parameters are super useful, and this is where you need to play and configure your drone if you want to go to the advanced section. So I have an advanced class, go and check that out if you haven't taken. That's very useful for managing drone, playing with the drone, configuring drone. But anyway, so now let's find over here frame. Okay, so we're gonna go down and look here, frame section. Okay, so here the frame class is undefined. Okay, but if you scroll down over here, and here you'll see that so 0 means undefined, 1 means quad. Okay, so over here we can just simply go ahead and select this. So the value is 1 right now. Now we're gonna write here. Okay, click on write params, and we're gonna save this. Okay, so save successfully, but then it says you have to reboot. Now to reboot, let's disconnect first. Okay, let's go ahead and click OK and disconnect. All right, and then I'm also gonna disconnect physically from my Pixhawk. So let's go ahead and do that. Okay, I did that. Okay, now I'm gonna connect my Pixhawk, and then I'm gonna connect over here as well. But before I connect, we need to wait for the beep beep sound. Okay, now we can go ahead and connect. All right, so now if you come over here and view the log, hopefully that's gone, so we don't have that issue anymore. Okay, so we don't have that issue, and this is cool. So in next section, in the setup section, we're going to see how to work with this acceleration thing. So this one, acceleration calibration, which comes from this mandatory hardware setup. So from this one, we're going to go ahead and work. Okay, so now we are going to do this calibration. To do this, I'm going to suggest you one thing. First, both of this GPS and the Pixhawk, they have to be on a flat surface. So I have this flat box over here. I mean, it's definitely not a box, it's like cubic, but anyway, the surface is boxed over here. So I put them, so that's a flat. And then at the same time, I have this nose. So the quadcopter direction, heading direction, and the GPS heading direction, they are to the same direction. Okay, so you have to make sure that one. Now the reason why I put them here, because I put some sticky glue over here so that it's easy for me to do the calibration. So you'll see when I do that, okay, that why it's important. All right. Okay, so we're gonna start calibration. The first thing you have to do, make sure it's on a flat surface, and if you find a square box, it's definitely gonna help you. Okay, so the first thing over here, so we have to click on calibrate SL. So let's go ahead and click on this, and it says that place the vehicle level. Okay, please place vehicle level. Okay, and then it says click when done. So we did that, so it's level right now. We are done, and so we're gonna click done. All right, so now next follow me. It says that please place vehicle left. Okay, so it is asking you to put it on the left direction, so just like this. Okay, so now, because if you have sticky glue below it, it's easy to do this, otherwise they might drop, right? So now over here, this one, so it says click when done, so we are done. So I'm going to click on this, done, and then here it says please place vehicle right. So here we're going to do it right. Okay, make sure that you do it right. Okay, all right, done. And then please place vehicle nose down. So these are the nose over here, both GPS and our campus. Okay, all right, so here we are done, so click done. Now here it says nose up, so here the nose gonna go up, and make sure that it's still flat. Okay, you have to make sure that it's still flat. Okay, all right, and then click done. Now here it says vehicle back, so we're gonna have this forward and back it like this. Okay, so you have to do it. All right, and then here done. So it says calibration is successful. So once that is done over here, now we're gonna come back and check our data over here. Okay, so now it should be flat. As you can see that it is flat, and this is what you want to achieve during acceleration calibration. Okay, because if it is not flat, it's not going to, I mean, when you fly, you're gonna have random directions, random flying, and which can cause a lot of issue. Okay, so that's what we did. All right, wonderful. So then in the next section, we are going to go ahead and do this setup over here, the campus setup. Okay, so we have to go ahead and do that. So let's go ahead and do it. So as usual, I'm going to put them together. It doesn't really matter, so as they are. And in general, when you start doing campus calibration, your campus should head north, both of them. Okay, now from this over here, it is not north, because as you can see, it is 232 degrees. So if they're facing north, so the campus north and the earth north, they will face parallel, so that means that they should be 0. So to know, so I'm gonna rotate like this. Okay, so for me it's this direction. Okay, so pretty much this should be my north. Now of course there could be some offset or wrong, like plus minus 10, but you can ignore that. Okay, all right, so you can do this, it doesn't matter. All right, okay, so once you do this, now you're gonna come back to this setup over here and make sure that 2 of your campuses are over here. So the one that is I2C, which is inner integrated surface, which actually the external campus, the GPS has, that has to be there, and SPI, the one that Pixhawk itself has. Okay, so we're gonna have both of them together. All right, and over here we're gonna choose campus 1 and campus 2, because we'll just have 2 campuses over here. All right, now I have other videos. If your campus current setup doesn't look like this, how to go ahead and fix that, I have other videos, go and check that. Okay, on YouTube. All right, anyway, so once you have this 2 ready, we can go ahead and start campus calibration. Make sure that they are none. All right. Okay, cool. Now to do that, over here we're gonna say start. All right, so now we're gonna start calibration. All right, as you can see, like this. Okay, you can do up and down like this. All right. All right, you can do like this. You could do like this. Okay, all the directions possible. All right. All right, now here we could do like this. Here we could do like this. Okay, so soon we'll be done with the calibration. And looks like the calibration started again. So not sure why, but we'll continue it second time. Also, there are errors. In general, if you don't get good result, you may do it few times, and it happens. First time might not be good enough. So we see our second campus most probably done. Over here we see that. So now we are waiting for the first one, which should be I think the external campus in this case. So let's continue to do that. In general, it doesn't take that many times. You may be done with the first time. If you're done with the first time, you'll see the blue square. Okay, one of them is done. Now, as you do that, make sure that you don't have a lot of metals around you. The problem is, as I'm doing, there are a lot of metals around me. So it could affect it the way we do. Okay, so after doing a few times, my calibration has been successful, and now it's asking me to reboot the autopilot. We're going to do that. So here we're going to disconnect, and then I'm going to disconnect from here, and then I'm going to connect it back. So we're waiting for the beep beep sound, which definitely will appear, and then after that, okay, so we see the light blinking, and now we can go ahead and connect. Okay, now we're gonna go and see our data. Okay, so whether the data is correct or not. Okay, so it's on the flat surface, we see that, so it should be good. All right, so sometimes it's not flat due to my surface over here, but it should be good. And then over here, if you turn it to north, in your north, it should be 0. If it is not, then you have to do the calibration again. Okay, it's better that it is close to 0. All right. Okay. So now I put it forward. So that's what I see, and my surface looks. Okay, so here we go. Right now over here, I have this FSIA6B. Now this one is a receiver. Now this receiver, we have to connect it with our Pixhawk. Now to connect it, we can use this wire, this cable. This is called female to female. Now this receiver itself over here has PPM ports, which means that we would be able to connect it directly here. Okay, but now one thing though, a lot of time actually you also may seen that some people connect with this kind of PPM encoder. So here it's written PPM encoder. Okay, so now this PPM encoder, we can also use this one. Okay, this also works, but as you can see from the cables, it has a lot of complex wiring, but it works. Okay, but a lot of modern FSIA 6B receivers, they also have built-in PPM encoder inside them. So that's why you don't need an external encoder like this, but you may see a lot of tutorials out there they use this. So in our case, we are not going to use this. We are just going to use this female to female wire. Now the way you'd be connecting is like this. So over here you will see that ppm and channel ch1 like this, and then we're going to connect it with our Pixhawk. Now the Pixhawk itself is ready, we already calibrated it. So in general, the last part over here where it says that RCN, right next to it, the last one over here, you're going to connect it like this. But the problem is, if we connect it like this, it's not going to work, because the first thing we have to do, we have to bind this receiver with our transmitter. Okay, so connecting like this yet not gonna work. Okay, so I'm gonna unplug this. All right, so I'm gonna move aside our Pixhawk over here. Now over here I have this transmitter. So this is the transmitter that we're gonna bind this. Okay, these two together, we have to bind it. And in next tutorial we're gonna do, and in next tutorial we're gonna connect our Pixhawk, this receiver, transmitter, all of them together, and we are one step closer to fly our aeroplane. Okay, so now we are going to bind this receiver with this transmitter. Remember, when you bought this FlySky, they all came together in a package. They should come together in a package. Okay, so you have to know that one. All right, if you don't have all of this together, so that's a problem. Now here, this is called binding plug or binding key. So we have to use this one to, bind these things all together. So the very first thing I'm going to do is connect this over here, like where it says B/VCC. So the first B is for binding. So you're gonna plug in like this over here. So that's the first thing. But to be able to work with this binding, we need to power up this receiver. And of course, you also have to power up this FlySky. So you should have batteries in it. All right. And then you need a LiPo battery. So I already have. Any kind of LiPo battery would work as long as it can supply power, or any other batteries, that's fine. Okay, so the one thing you could do right here, so we are going to connect them together. So LiPo battery, make sure it has power. So this is an ESC, electronic speed controller. So in general, when you work like this, of course you have an electronic speed controller, so you have to get one. So make sure that you get one, and then over here you're going to connect them. All right, so now they're connected, but this time I'm going to take this female wire, this 3, and I'm going to plug it in here. And as you do that, make sure that this one, the yellow one, stays at the top and the brown one goes down. All right, you have to make sure, otherwise you're gonna destroy or burn this. It could be bad. So the yellow one stays up and this one goes down. And then over here, any of them plug in. All right, so as you do that, you see it starts blinking. So when it starts blinking, that means that it is waiting for to be connected with the FlySky. All right, so as soon as we connect here with this FlySky, the blinking would stop. All right, okay, right. So I'm gonna put it here so that you can see the blinking. Now for this FlySky itself, here you're gonna click on this and then push it up. All right, so it's trying to bind and the blinking stopped. And over here you do see that it has voltage transmitter, this one, and there is also a receiver that that voltage is 4.9 and the transmitter itself is 5.4, and then there's also signal information. So now with this, the binding of this receiver and this transmitter, they're done. Okay, now of course if this is done, then we can unplug this. We don't need this thing. You only need this for during binding. Okay, so since the binding is done, in next part we'll go and do the radio calibration. Here we go. So we have more setup to do. So this is our transmitter. Make sure that you turn on your transmitter. Now the very first setup that we need to do, again, I wouldn't say very first, but we need this setup. So over here I'm going to click OK, and then I'm going to make sure that this is selected, the system setup, the first one. Okay, click OK. All right, go down, and here let's go ahead and click on the RX setup, this one. All right, and then go down again, and then here we need to make sure that our output mode, okay, so our output mode should be selected ppm. Make sure you do that, and everything else you can keep the same as before. But for me, the thing is that I already set this up to ppm. For you, if your receiver is new and if you're using FlySky along with me, then it should be PWM, but we are not going to use PWM. We are going to use ppm, and I will explain the reason later in the second coming tutorial. All right, okay, so make sure that you go ahead and do that. All right, so now after that, go ahead and do long click. It should be saved, and then you can cancel it, go back, and whether the setup took effect or not, you can always come back and go down and check it. So here looks like it didn't save, so I might have I haven't clicked on this one. So go ahead and long click on the cancel button. Okay, now it did. Now you click again and you will see that it's ppm. So make sure that you have this. Okay, so we need more setup before we go and do radio calibration. So that's very important. But anyway, so make sure here you're on a home page. So let's click on this, long press, and go to the system over here. And we're gonna click OK. And we're gonna go down outside, okay, to the last mode possible, which is called aux switches. So now this one here, you have SWA, SWC, SW. These things, all the switches, actually they refer to this switches over here. Okay, all right, so right now it looks like by default this one is enabled. Okay, so and you can also see that it's pointed to this one. All right, so I think the point, you could change the point by clicking this, like this button. Okay, but before you change the pointing, one thing you have to do, click on this. So whatever you select, so for example, you select this one, so this is for selecting, right? So now with this, you have to select, say for example we are working with SWA, then it should be on, but when you come here maybe it is off, so make sure that it is on. So you can toggle using this one, so make sure that this is on. So we're going to make sure all of them are on. So I'm gonna go to the next one. So I'm gonna make sure that this is on, all right, by clicking on this one. So, and then we are pointing to SWC. So that should be now our setup, because we want to point to this one, all right. So make sure that this is SWC, because now here it should be marked as SWC. Okay, all right. So now let's go ahead and press long. All right. So now it is saved. Whether it's saved or not, you can click once more time and check this. All right, so it looks like it is all saved. All right, so now we're gonna go back, and then we're gonna go down this one over here, and then over here there is something called aux channels. Okay, so we need to make sure that our setup is correct by coming over here. So let's click OK, and then looks like channel 5 is pointing to VRA, which is actually this one, but we don't want it to point to this one. We actually want it to point to this switch. Okay, all right, now to point it to this switch here, you can just click on this and make sure that it's WC. It could be anything, but we need to make sure that it's SWC. So this 3-position switch. Okay, you have to have this one. Make sure that you do, because basically in this tutorial we're going to use this one to control our flight mode. If you don't know flight mode, we'll talk about that later. So make sure that this setup is correct. Other setup, just leave as they are. And then long press. So make sure that it's saved, but you can click on it again. And looks like it is saved over here. Okay, so now with this, we are ready. But next tutorial would be one more tutorial that's about theory, which you should understand. Okay, and next tutorial we'll go back to our actual practicing of mission planner and this thing. All right, I know it's a bit of a long time, but I want you to understand that how everything works. So in this section, I'll explain pretty much a theory that you should understand here, why we have all these things and the way we made the setup. It's very important to understand. The first thing is that our receiver, if you come to the system over here, you'll click OK, and then you'll go down, and then here you'll see OK. And then here I go down one more time, and here the output mode. So here we have selected PPM. We could have gone with PWM, but that's a little more complex setup, as I said that. So now with this, we are saying that, okay, this is our transmitter. Whatever it does, it should output something as called PPM, okay? Pulse position modulation, I think that's what they call it, okay? So that means that here the setup would output as a PPM. Now our receiver, this is a receiver, and if you see the receiver carefully, so it also has a PPM channel, okay? So that means over here, whatever I transmit, then this one over here would receive as a PPM. So I'm outputting PPM, then I'm taking it over here as a PPM signal. Now, as everything happens over here, PPM signal, now this one would be connected to our, Pixhawk, right? So now Pixhawk would read that information. Whatever comes here as a PPM, it would take that and it would read from this port, okay? So with this, the PPM is read, all right? Now, as this thing happens over here, and as we move the switch over here, everything would go as PPM, all right? So it would come over here, and then it would go to our Pixhawk. Okay, now one thing over here, this channel. So this is called here, this SWC, this one, we just assign to channel 5, okay? So now as you do that, this channel 5, it has 3 positions, okay? It has this 3 positions. So these 3 positions, we can use them to control our flight mode. What do I mean by that? That means that you can do alt hold, where it would go up and then have same vertical level that would do that. It could be hovering, which needs GPS log, and it could be land mode. Okay, a lot of modes could be said using this 3 positions. Okay, so each time you take them to a position, it would do a certain thing about flying. Okay, now everything would go to the our receiver, okay, as PPM, and the receiver would pass it to our Pixhawk. Now over here, why channel 5, right? So we have channel 5 thing because our autopilot, which is our flight controller software, and of course we have Pixhawk, the hardware. So autopilot always expect channel 5. So if you're using the autopilot, it uses channel 5 to control the flight mode. So it listens to something called a channel 5. So now if our channel 5 is activated and then we assign this flight mode, so autopilot would go ahead and first listen to channel 5, and then also it would listen to each position, okay? So as it does it, now then it can control the hardware. So you have to understand the basic thing, and hopefully this helps you. So we're going to move to the next tutorial. Okay, so in this section, we'll really go ahead and do radio calibration. Now to do that, make sure that we have these things already. We have our transmitter and the receiver and Pixhawk, okay? And then at the same time, we have to make sure that our autopilot is open, okay? All right, and then this is the COM port that I'm going to use. Most probably, it should be this one, I guess. Because the other one is Bluetooth, and let's try to connect. And it's connecting, so it's going to work. All right. The other thing that, because I just want to focus on the receiver and the transmitter and the Pixhawk, all three connection. So I have removed other cables. We don't need them because this is just a radio calibration. We can do it independently. All right. Okay. So right now for our receiver, so this is the receiver, as you can see. All right. So you should have this wire. Okay. Now, once you have this wire, make sure that you take the wire and connect it here. The channel says, you can say PPM, CH1 over here, and make sure the signal wire is at the top. The black one is at the bottom. It's very important. Otherwise, you may burn the receiver. So that's the first thing. And then over here, you will see this is our Pixhawk, right? So this Pixhawk over here, it has this the last one where it says that RC in, okay, and below it this I think this minus, plus, and S. Okay, so S means the signal. So in this case, the signal is the yellow one, it should go down, okay, and the brown one or the black one should go up. So it's the opposite than this one. So you have to connect it like this. So we did all the work with PPM. All right, everything is done with PPM. So right now over here, you see that it's blinking. So this power supply is coming. It's connected with Pixhawk. And now all we need to do, we need to work with this radio, which means our FlySky. Okay, now if we want to work with this, so we need to switch it on over here. All right, make sure this sticks it down. And then here we'll see that it's connected and the blinking is gone. So that means that everything is well connected over here. Okay, right now, since this is well connected, now we're gonna go to our setup. Okay, remember earlier setup are already saved in your Pixhawk. Even if you remove the wiring, it's fine, it's totally fine. So here we have this mandatory setup, and then we go to the radio calibration. Now this is where we're going to do the radio calibration. So in general, right now, if you see that this is our left stick, okay, so this is the throttle. Remember, this is the throttle, and this is also responsible for yaw. So as you can see that, so that's connected with here our channel, I guess RC3 and RC4. Yeah, that's right. Okay, so this one yaw and this one throttle. Okay, the throttle means going up and down, and this is means rotating. Okay, all right, and this is for pitch. Okay, back and forth, and this is roll, left and right. Okay, so this is already connected. So in my case, I have already done the calibration once, but it doesn't matter, we can do it again. All right, so if you don't see it like this, it's fine. So the thing you need to do over here, you need to go ahead and click calibrate radio, and here it says that the transmitter is on, the receiver is powered, and the connection motor doesn't have power or no props. Okay, so we don't have any motors or props here, so it's totally fine. And then over here it says okay, and then here it says click, and then it says RC sticks and switches to the extreme position, so the red bars hit the limit. So we'll see the red bars. Okay, now here we're going to start doing calibration. So now as you can see that I'm moving the throttle stick up and down, left and right, okay, to their extreme. You can do this. We can also do this one over here. Okay, now we can do all of them together. Okay, it doesn't matter. Okay, all right, the other thing, this switches. Okay, right, so once this is done over here, okay, now we're gonna say done. But here we have this, it says that ensure all your sticks are centered and throttle is down. Okay, so throttle is down and other stick, well, this one centered, and click OK. All right, so we're gonna click OK. Now with this we are done, and it gave you a brief summary of the calibration, the channels, their maximum and minimum, and they're pretty correct. Okay, it should be as close as 1000 and it should be as close as 2000, but there should be some variation based on hardware and everything, so but it's still okay as long as there is no huge difference. Okay, so now with this our radio calibration is done. Okay, so let's continue. Before we dive in to fly, we need to work with this battery. So hopefully you have this battery. I'm using this where it says this 5200 milliamp, so I'm using this one. For you it could be 2200, 3200, and I'm also using a 3S battery. So as you can see that So this is a LiPo battery, 3S LiPo battery. So the first thing you need to do, you need to go ahead and check the voltage. Okay, now I have a multimeter over here. So this is the multimeter that I'm going to use. Of course, there are other ways to measure the voltage of this. Okay, all right. So basically, what I'm going to do over here, just insert this thing over here. Okay, and then we'll see the reading. Okay, so in my case, I see if it's stable, it would be around 12 voltage. Okay, it's fluctuating. As you can see now, it's 12.64. So I'll read it as 12.6. Okay, now that means that over here, as you can see that, okay, I don't like that. Okay, so it's above 12, but because I'm moving, so it's not getting a constant similar output. Okay, now I think you can see that that's the 12.64 voltage. So now over here, this is after full charge. So you have to full charge your battery, LiPo battery, and then you can read it. Okay, you have to read the reading using a multimeter, or there are other ways actually. So you can also use those methods. All right, so we need this one. You don't need the exact one, but you have to be approximate. So I'm gonna, in my case, it's 12.64, but I'm gonna put in 12.6. Now put in where? Now I'm gonna release this. I don't need this now. Okay, so the reading was important. As we did the reading over here, now we need to come to this flight mode over here. We came here before actually. Right now we need to go to this optional hardware. Okay, so now we're gonna go to the setup over here and optional hardware, battery monitor, and make sure that these are all selected. Analog voltage and current, other, the cube and Pixhawk. And now over here, if your battery has whatever the milliamp you have, right in over here. For me, the battery is a little big, 5200. A lot of you may have 2200 or 3200, it doesn't matter. So just go ahead and type in there. And then over here, the value that we had just measured with the multimeter, we're gonna type in here. So for my case, that was 12.60, and it should be the typical one most of the time, and hit enter. All right, so as you see that as soon as you hit enter, it changed over here. Okay, all right, so now it should be there, but sometimes it does fluctuate, but you can ignore that. It should be close to your measured voltage. But once you put the voltage over here, so it's going to go ahead and recalculate for you and put it here, because that's what the Pixel reads from the hardware. Okay, because what you do is using the multimeter, but then Pixhawk has a way to read the actual voltage, and that's the calculated one. Okay, so now with this battery setup has been done. Okay, so here we are going to talk about 3 failsafe mode, and we should have them and try to understand a little bit that why they're important. Okay, so the first one is over here, the battery itself. So previously we have seen the battery, and if the battery voltage together is below 10.5 voltage, so we should enter a failsafe mode, because Pixhawk, so the hardware can detect that battery is below or less than 10.5 voltage. In that case, we say, okay, go ahead and land. It means land immediately. Okay, wherever you are flying from that position, you land. That means that save the battery and save the hardware, because if you draw more voltage and current, you're going to destroy the battery. So you don't want to do that. You want to land and disarm. So that's what happens here. And then over here for radio, that means that if you're connected with the transmitter, and then if you lose connection with the transmitter, you should always return back home. Okay, always return back home, or return to launch. Actually, in general, launching point is your home point most of the time, so you should have this one as well. So lose connection, go back to the launching point. And there is also this failsafe PWM, so you have to set it around 975. This is the basic default setup, which means that whenever we connect with the transmitter and receiver, so transmitter sends PWM values between 1000 and 2000. That's the value, right? So within that, our receiver transmitter, they work. But if the radio is, the transmitter is lost, or transmitter has a problem, or it doesn't have signal. So in general, that's below 1000. So if it goes below 975, which means that you should actually return to launch as well. Okay, so that's the meaning. There is a very low PWM value, so something is wrong. In that case, return to launch. So that's the idea. Okay, so they all work together for failsafe mode. So some things go wrong. So in that case, battery goes wrong, will land. And if I have problem with the receiver, transmitter, or PWM values, then you should return to launch site. So that's how they work. Okay, thank you.
All right, so in this case, so far we have seen a lot of theory, how does the Pixhawk work and how to tune the Pixhawk. I mean that basic tuning, like radio calibration, compass calibration, acceleration calibration. Okay, so different kind of things we have seen so far, but in this tutorial we are going to cover how to put all the hardware together so that we can do further test. Okay, so that's what we'll be focusing on. Now, a lot of the time in this case I'm not going to talk, because you can just follow along and you are good to go. All right, okay, so make sure all these hardwares, they're all here, so that in one go we can try all of them. So we have seen a lot of work with the Pixhawk and how we tune the Pixhawk and everything else together. Okay, and we have also done the acceleration calibration, radio calibration, compass calibration, and we have also seen a bit of motor test. But now here we going to put all these things together. Okay, so we're going to assemble the drone so that we are ready to fly. Now, as I do the assembling, I might not be talking all the time, so you can just follow along with me. Anyway, the very first thing we are going to do is this part. This one I'm going to move aside, because this you may use, you may not use, it doesn't really matter. So we may do that at the very last part of this video. So the very first part that you should do is this one, assembling this one. So I'm going to go ahead and do that so you can follow along with me. All right, so we're going to make sure that this two sticks, these two arms actually, so they are in the front part, but of course right now we don't have any front and back, so it doesn't really matter what is front, what is the back one. So in general, this would be the forward. Okay, this is where our nose of the Pixhawk should pointing forward, right? So we're going to start putting them together. All right, so get the small screw and just use these handles to work with them. So if you have these handles, actually it's quite handy to screw the screw over here, as you can see that. Okay, so it's better to get the handles, but these are not always necessary, because you can also do them slowly in your free time using your hand. It doesn't really matter, but I like it to be convenient. Okay, so I'm done with the very first part. Once again, my frame may look old because I've been using them for quite a long time. Okay, anyway, that's not the point. So now we're gonna flip it over and I'm gonna continue to work on this, and this part could be also a little bit tricky at how it works. Okay, all right, so it doesn't matter, just put like this and continue to put the screw. But now over here, even though I said that we're gonna do it later, but even now we can do it right now, right away. So we're gonna go ahead and do that, okay, so that we don't have to repeat ourselves. So it looks like I'm almost done with this frame setup, but now all I need to do is tighten all the screw, because the motors, they vibrate a lot and a lot of them could actually lose, and you may lose the screw, and then eventually it may cause crash. So you don't want to do that. So once again, it's better you go ahead and get this handle. This handle can definitely help you. Now, not only that, I'm going to tighten the screws, the one that we have over here. Okay, it's quite important that you do this, otherwise they'll lose and motors may lose eventually, and then the whole vehicle may crash eventually. You don't want to do that, because drones are in fact very unstable vehicle, much more unstable than any kind of traditional robots. Okay, drones are included part of robots, but they are very unstable due to the nature that they fly, and they have to depend on motors. And because a lot of the time motors define the whether a drone is good or bad, because motor plays a very important role. So if the motors are bad, definitely a lot of things go bad. But anyway, the idea over here, I'm talking about screwing them tightly so that they don't lose. All right, so the next part is working with this motors that we're gonna put them there and connect them. So the way I'm going to do over here, I'll try to have 4 of them actually over here. Now this may look a little inconvenient, so here I'm gonna put all this over here. Okay, now this part just takes time and patience, not much. So make sure that holes they align, and then you're good to go. So wow, here we are done with 2 motors. Okay, we're good to go. All right, looks like this motor is missing the top, but it's okay. I have a lot of tops. Most probably it was this one. It just fell down, but it's okay. Now I'm gonna go for this 2 over here. Now we're gonna go for the last one. So this putting the motors and the frame, actually it requires a lot of strength and energy, and sometimes it's also time, because the screws are very small, and if you don't have the handle the way that I bought the handle, so they're quite convenient. Okay, I'm done setting up all the motors, but one thing I cannot stress enough, that make sure that they're tight enough, otherwise the motors, they vibrate hugely, okay, because they are going to rotate, I think, more than 1000 times a second, so you have to tighten them carefully, otherwise they're just gonna go ahead and get lost, and eventually it may be cause of your vehicle crash. So all right, so now our drone is half ready. The next thing we need to do with this power splitter and the ESCs, we're going to connect them together. Now you'll see that my ESCs, they look a little bit different and little, how to say, messy, but it is not actually. If you bought this BL Heli, this ESCs, they actually have 3 wires that we should connect with Pixhawk. So but there is one in the middle, that's a red one. In my case it's missing because I already cut it off, because we don't need the red one, because we don't need the middle wire. So for powering the ESCs we don't need that, so you can just simply go ahead and cut it off. I did for all 4 of this ESCs, so it looks like it's, how to say, the wires are off, or I don't have enough wires, but for each of them I just remove the red one. Make sure that you do this. Okay, now you should have a power splitter. Now this power splitter you could build on your own one if you know how to do the soldering, but I suggest to buy one. It's very convenient. All right, so now the first thing that we're gonna do with each of this, just connect like this, make sure red to red, black to black, and you are good to go. Okay, so now since this is done, what I'm going to do, I'm gonna put it, for now I'm gonna put them freely actually, but it could be very good organized. For example, you can take 2 of these ESCs from below down. Okay, this way the wires, they are not going to randomly flow around or move around, which is bad and could be very dangerous sometimes. Due to the beginners, the way they operate the drone, or if you have a wrong setup, it's definitely gonna crash. Okay, so if it crashes, and it does actually, and it could be frustrating, I know, but it's a very common thing as you are learning to build your own drones. Okay, it's a quite common thing, so we're gonna take it easy, and we're gonna be try to save as much as possible. So over here, okay, right now 2 of the ESCs are here and 2 of the other ESCs are here. Okay, so one thing I would like to tell you that, so if this is our Pixhawk, and then in my case this is our Pixhawk, we know that. All right, so we're gonna level it, but if you want to level it, you may use some sticky glue or vibration dampener okay, which is what I've already done it. Okay, you can buy them, and at the same time you can stick them. It's good and stable, and you can push a little hard, so you're gonna get stuck there. Okay, and make sure that it does get stuck. All right. Okay, right. So now in our case, the drone, so the drone is forward facing. So remember, in this case, this would be our first motor, this would be our second motor, and this would be our third one, this would be the third one. Okay, this would be the third one, this would be the fourth one. One more time, this is the first one, second one, the third one, and the fourth one. Okay, so one thing I would like to tell you, that we're gonna rotate this and the one in the corner, we're gonna rotate them clockwise. Remember, these two clockwise. Okay, so they're gonna rotate clockwise, and this, the other one here in this diagonal. Okay, so they're gonna rotate anti-clockwise. That's what we have to remember. Okay, all right. Now then, this is our ESC, the connectors that we should connect with the motors. Now to do that, over here, the first thing, remember, to work with the motors over here, each ESC, the middle one is the signal one. Okay, the middle one, the middle cable, that's the signal one. So you're going to connect it with this yellow one. Okay, for now, and then the other red one could be with anyone, and then the black one. Okay, so you should follow the same. All right, so that was the first one, and now over here I'm going to go for the second one. All right, and then the same goes over here, the middle one to the middle one, and then this red and black, it doesn't really matter directly. We may have to change them, because even though we want this one to rotate clockwise and this one to rotate anti-clockwise, but we don't know their rotation yet. So to know the rotation, we have to swipe this two. Okay, if they rotate as we want it, we don't have to change anything, but we may have to. Now I'm gonna go for the third one. Okay, so once again, the idea is over here, you connect like this. All right, now we're gonna take these two cables over here from the first motor. We're gonna put over here the one, it says 1, main out 1, so right with it. Okay, all right, so this serial, the connection matters, and next one should be this one over here. So this is the second motor. Okay, now we're gonna take the third one, which is this one. So remember, the black side goes up, because for Pixhawk, over here we have a lot of connectors, and the first level of connectors, these are all for ground. All right, now over here we're gonna take this one and we're gonna connect the fourth one. Okay, all right, so with this we are almost done with the basic setup. Now here we have this receiver. Okay, as you can see, the receiver is here. So I already put a dampener as well as glue, so that I can just put it right here. Okay, all right, and then this 3 cable, one of this I'm going to connect with the very last port of the Pixhawk over here, the very last one. And once again, we make sure the black or the brown stays at the top. Now the rest of the things are going to be very easy. Now here I have this buzzer, so definitely the buzzer goes here. Sorry, here I have this hardware safety switch, so it goes here. And then I have this buzzer. Now this buzzer, once again, this is an old buzzer, so I'm gonna put it here. where it says buzzer. All right, and then this is the power module. Now I'm gonna put the power module over here where it says power. All right, and the last part is the GPS module. So I'm gonna take this, and this one is going to go for the GPS part where it says GPS, and then the other part should go to this I2C, which is inner integrated circuit. So let's go ahead and put it here as well. Okay, right. All right, now over here you have seen that we have this power module, and this is coming from the power splitter, right? So here we're gonna put them together like this. Okay, so if so, the battery should go here. Okay, now I'm gonna go ahead and put the battery on. Before you go ahead and do this, actually you could tighten them somehow with cos tape or tape. All right, okay, which I'm not going to do it here. So here I'm going to connect them. So let's go ahead and do this. Okay, right, so it looks like everything is powered up. Okay, yes, the Pixhawk has been boot up, so it's loaded into the memory, and we can see the light is on, flashlight. Now it's not yet connected with the receiver. Okay, now to connect it with the receiver, over here all we got to go ahead and do, switch it on. All right, and then it's gonna auto connect, and it's connected. All right, so the whole thing has been connected. All right, okay, so in this section we're gonna see how to mount this GPS device, this GPS module on the Pixhawk over here. Now remember, when you buy this GPS, it should give you a stick like this, and if you don't have, you should get one. Of course, originally it was not like this, so let me show you. So over here, the way you need to connect it, let me show you over here. So as you see that this part is like here, you can change the direction of this thing, the stick itself. Okay, so here you need to use a screw. That screw should come with this, and as well as over here. Now this is the tricky one, so if you want to work with this, most probably you need something like this. Okay, right, so anyway, so once you do that, so you can just screw it tight so that it doesn't get unscrew or fall. Now over here in this section, as you see that I also have another screw to connect with this small plate, I would say. Okay, now I'm gonna put it like this. This is the GPS device, okay, over here, and I'm gonna make sure that my GPS, when I put it on it, the direction is same. So let me show you. So here I put it like this. So now what we need to do, you will see that over here we were supposed to have two screws. Well, I have already unscrewed them over here. Now my stick and GPS looks like this. So I'm going to have it like in this direction, okay, or actually this direction, so that my GPS and the Pixhawk, they point to the same direction. This is super important for stable flight and to avoid emergency any kind of unnecessary crash. Okay, all right, so make sure that the holes over here, this and this, they align. Okay, right, now once you did this, so you need to take a screw and start to push it inside, or use the handle to tighten it. It's super important. You need to tighten it well, because initially when you start to fly, you may have one or two crashes. Now if you do have crash, this GPS module may fall, or get detached from our Pixhawk, the F450 frame. So we need to make sure that it doesn't, so you need to tighten it hard. All right, so now
I already did that. Okay, all right. So the next thing we need to do over here, so there should be this cable, the thick one. So we need to bind it using something like this. Okay, I think it's a metal cable, but very thin metal. So you can use this to tight it over here. So that's what I'm going to do. Okay, so if you do tight it, it may look like this. Did you see that over here? Okay, now with this, it shouldn't change its direction as the Pixhawk flies, because Pixhawk does, or our drone, the whole system may have a lot of vibration. Okay, so it's important that all the components you put together and screw them tightly. Otherwise, they may lose them during flight, and it happened. Initially, it happened to me. So make sure all of them are well screwed all in all the places. So this is quite important. Anyway, once that is done over here, now these two parts, the small one, it should go to I2C, which is inner integrated circuit. So let me go ahead and put it here. Okay, the other part, definitely it should go for GPS section over here. Okay, right. Now with this will stay hard on it. Okay, make sure that you tighten it hard. All right, okay, cool. Now once this is done, I'm going to go ahead and in next section we are going to work with the motor spinning direction, and we may also need to work on this section over here. Actually, right now the way they are, this four, they may have problems, so in next tutorial we'll go ahead and fix them. So here we are going to see how to do the calibration with this transmitter and the ESC that we are using. Okay, the ESC that we have. So we have to do the calibration with the transmitter so that the throttle that we have, this one, it works well correctly with minimum and maximum PMW it recognizes, or minimum or maximum throttle. Now to do that, the first thing we need to do, we need to switch on the transmitter. So let's go ahead and do that. Okay, and one thing before you do that, make sure that your motors, they don't have any props. Okay, it should be without props. And then I'm gonna pull this up, the throttle to the maximum, as you can see over here. And right now we're going to do another operation with this battery. Now what we'll do, first we'll plug the battery and we'll wait for a beep sound, and then we'll unplug it, and then we'll plug it again, and then we'll keep the battery there as plugged, and a lot of other things will happen after that. So that's what I wanted to say. Okay, so the first thing over here, the battery is ready, and this is my power module, so I'm going to connect them together. Okay, all right, so I'm gonna wait for the beep sound. Okay, I heard that. Now I'm gonna unplug this. Okay, so I'm gonna plug it again one more time. All right, now we're gonna wait for the beep sound again, and we'll continue to wait for it. So okay, now it's I'm hearing the sound. Now here I have this hardware safety button. Okay, I'm gonna push it down. Now here you are hearing the sound. Okay, this is all being calibrated with the transmitter and the ESC. Okay, now since this is done, now I'm gonna take this transmitter over here. So remember, this is our throttle. So I'm gonna pull it down like this. Okay, all right. So okay, let's wait for it. Okay, so now what we need to do, we're gonna pull this up slowly. So as you see that my motors, they're rotating. As you can see, one of the motors, actually all the motors are rotating. Okay, this is the other motor, as you can see over here, and this is the other one, and the one there at the top. Okay, right? So motors are rotating. So now as you pull it up over here slowly, this one, okay, so they are going to increase in rotation, all right, and pull it down. Okay, so all the motors, they have stopped. So now as we do that, the maximum and minimum, our ESC recognize the PMW, and it also recognizes the lowest PMW. Okay, so now this is very important. And another thing is, you do that, make sure that this motors, whenever you slightly pull it up over here, all the motors, they should spin equally. Okay, and they should start at the same time. You have to make sure that they start at the same time. Okay, it's very important. If they don't start at the same time, something is wrong. So in my case, I'm seeing all the motors, the one that I see like this, they're all rotating, and every one is starting at the same time. So make sure that you have this one. Okay, so if you have this one, you're almost at the end of flying. Okay, so make sure that you have this props, the motors, they switch on, or they start to rotate all at the same time. This is quite important. So here we're going to see how to set up the pause hold mode. The very first thing you're going to do, you're going to come to this config over here, and then actually not config, I'm sorry. So we're going to go to this setup, and after that over here we're going to go for this mandatory hardware, and once we go there, we're going to go to flight modes. Okay, now in general, for pause hold mode, we're gonna, as always, we'll have the first one, stabilize, and the fourth one will have this pause hold mode, and the third one is land mode, or even some of you may select RTL mode. Okay, all right, so for now we're going to keep it as RTL mode. Okay, so wherever you start from, and if you do the last part of this switch button, which means that to the bottom, so it's gonna come back to its position. We'll see that how it works. Okay, so we're gonna save it. It's done. Make sure that your transmitter and receiver, they're well connected, and then when you change the switch, you'll see that it works like this. So when the switch is at the top, it's stabilized. When it's middle, we'll see it's pause hold, and then at the end it's RTL mode.
Okay, so in this diagram, we're going to see how should we rotate our motors. Okay, now if this is our Pixhawk, you know that Pixhawk has a nose direction, so make sure that your Pixhawk is set like this, forward direction. And if it is forward direction, on the top right, the very first one, we're gonna mark it as our first motor, and on the diagonal direction, the second, this one, we're gonna mark as our second motor. Okay, and both of this motor, they should rotate anti-clockwise, as you can see that. Okay, and the other two, they should rotate clockwise. Okay, so on the top left side, that motor is a third motor, and on the diagonal side, that is our fourth motor, and they should rotate clockwise, as you can see from the direction. Okay, and if some of the motors, they don't rotate the right way we want, we're gonna see how to fix them. It would be simple fix, just switch the ESC wires and motor wires, switch between any two, and you are good to go. Anyway, let's go ahead to work with our hardware.
Okay, so let's go ahead. We are almost ready to fly, and before we want to fly, there are some setups, and there are some crucial setups in terms of the whole hardware. So now we're gonna view them. The very first thing, okay, so let me go ahead and tell you. So now this is the drone forward direction, okay, the nose direction, as you can see that. Okay, now the crucial setup over here is in terms of how they should rotate. Okay, and we'll follow the traditional convention. So in general, this one, the one that right top your motor, that should rotate anti-clockwise. So this should rotate anti-clockwise. Okay, there are other ways of doing that, like clockwise, but we're going to skip that part because that may increase difficulties for beginners. So we're going to follow conventional method. So this is the nose, and from the nose, the right top right top should be your anti-clockwise rotation, this one. Okay, now at the diagonal on the other part, this should be also anti-clockwise, so both of them should rotate anti-clockwise. Okay, like this, they should rotate like this, anti-clockwise, as you can see that. Okay, make sure that we do that, or we follow this thumb rule. Okay, anti-clockwise. Now this too should follow clockwise. All right, like this. All right, they should follow this. Okay, so left hand side rule, and for this too, right hand side for anti-clockwise, clockwise. So that's the first thing. Now once you connect this thing together, until you do the test like this ESC, so my ESC is here, right, and then the motor, they might not rotate clockwise or anti-clockwise as you expect, and what to do in that case. So in that case, all you need to do, as you will see that over here, this part, you need to go ahead and switch any two. Okay, switch any two. All right, switch any two cables and you're good to go. All right, any two, and you should check whether it's your desired rotation or not. Okay, so you should check all of them one by one. That's my point. Okay, so you go ahead and power up the battery. So battery over here, you connect the battery and you see the rotation. And if you see that, for example, this is clockwise rotation, that means we need to switch this any two cables. So we're gonna go ahead and check the direction is okay or not. Okay, now I'll take this one in an example, because I know this, all of this three are rotating in the right direction, but this may not. Now to check this, first we're gonna power up our vehicle. So let's go ahead and do that. Okay, all right, let's wait for the calibration to be done, and now we're gonna click on this hardware safety button. Okay, now it's ready. So as you heard the sound, now I'm gonna switch on over here. Okay, now I'm gonna push it to the left side. Now I'm gonna push it to the left side. Let's go ahead and do that. Okay, now as you can see that I'm trying to fill it. Okay, so I can see that my hand is rotating like this. So I think I was not in the camera, so let's do it one more time. So as you see that my hand is rotating like this. So this one definitely is rotating to the wrong direction. Okay, because this should rotate in this direction, which is not doing it. Okay, all right, now we can also go ahead and check others quickly. So I can check it and feel it that it is rotating clockwise the way I want. So this is fine. I know this is also rotating clockwise, so I can go ahead and simply touch and feel all of them. Okay, so I can see that. Okay, so these are all correct. Only this has a rotation problem. So this guy, now since this guy has a rotation problem, what we could do, we can change any of these two and swap. So I'm gonna change between this and this. Okay, I'm gonna change between these two. So I'm gonna unplug it. Okay, and I'm gonna unplug both of them. All right, now I'm gonna take this one and plug it. So as you see that I just swapped the way they were connected. Okay, now before we go ahead and fly, we need to make sure again that everything is set up correctly, because you just don't want to change and fly, and that's very dangerous. Okay, all right, so now here I'm gonna push it to the left side, and then I'm going to check it. Now it's rotating correctly. Okay, see that this rotation is correct. Okay, all of them, they're rotating correctly. Okay, right. Now, since all of them are rotating correctly, which is very important, because if they don't rotate correctly, your drone may flip. Okay, definitely they will flip. Okay, so that's the first thing in terms of hardware, the motors, the way they should rotate. All right. Now, how about this section over here? This section, the wires, how they should go. Okay, as you can see, there are some wires connected which come from our ESC, right? So we need to check on that one.
Okay, so another important thing that we need to check over here, right after we know the right orientation of the motors, I mean the right rotation, we know that now they have the right rotation. Now we need to make sure the ESC over here that's connect between the Pixhawk and our motor. So how to connect with our Pixhawk over here? So the ESC for the first motor, the one connected with the first motor, that ESC has cables. That cables we should connect with our Pixhawk, right? So the very first ESC that's connected with motor 1, the other two cable, you know, the signal and ground one, that should connect to the first one. So the ESC that's connect with this one, okay, right over here with the motor, we take the cable and plug it over here, okay? And the second one, this one, we plug it to the second one. You have to know that one. And this one, it should go to the third one. And this one, it should go to over here, okay? So we just have to make sure that we have the right connection, okay? And it has to be in this serial, in this system. 1, 2, 3, 4. One comes over here, the second one goes over here, the third one goes over here, the fourth one goes over here. Now let's go ahead and see our hardware.
So remember, the very first motor, our first motor is on the top right side, okay, the first motor. That should connect with this Pixhawk port number 1, as you can see that over here, okay, main out 1, okay, this is where it should go. Make sure the ESC that comes, these two cables over here, okay, the two cables over here, that they should connect to the very first one, okay, all right. And the other one on this diagonal, you should take this cables and it should connect to the main out 2, okay, it's pointed or written 2, all right. So these two, they should be next to each other, and then they should be, you know, like this, next to each other, and 1 and 2, they should take 1 and 2, all right. And then this one should connect to the third one over here, written 3, so you should check carefully. 1, 2, 3, main out 3, okay. And the fourth one should go for the fourth one, this one, okay. So once this setup is correct, your drone will not flip, okay. You have to make sure that your drone will not flip. Why? This is anti-clockwise, this is anti-clockwise, this is clockwise, this is clockwise, and this one goes to number 1, this one goes to number 2, this one goes to number 3, and this one goes to number 4, and then we are pretty much ready to fly.
Now this tutorial we're gonna walk you through how to fly with pause hold mode. Now to make sure, first you gotta make sure that your compass, this one, is well calibrated, okay, it is healthy, that's the one thing. And then you have to make sure that GPS is connected as well. And then over here we need to connect our Pixhawk, as you can see over here, with our PC over here. Now I'm doing this tutorial outside. The reason is I need good GPS signal. So one thing you have to do over here, once it's connected, make sure the port number is correct there. And then over here you have to see GPS 3D DPGS. Once you see this one, actually you are good and you are good to go. And then over here, down here, over here, as you will see that it says that stats, okay, so that means that the number of satellites it's connected with. So it may vary all the time, pretty much. It could be 10, 11, 12, but it's less than 10, don't try to fly, it'd be risky, okay. And once you connect that one, over here you'll see that, over here you will see that it's blinking green light and it's blinking fast. The faster the better, because sometimes you may have green light but not too fast, and that's still okay. All right, so it's around 10. If it's around 10 satellites that connected, but in my case that is 13, so it's blinking very fast. So if it does, that means that you are good to go, you're good to fly. Okay, so make sure that you check up all these things before you go and fly outside. Okay, this is very important if you want to fly in pause hold mode. Okay.
All right, so now in this section, we are going to go ahead and take a look how to set up some parameters before we fly. Now, this setup has to be done in our mission planner. Make sure that you are connected. Okay, make sure your comm is correct. And then here, I want you to come over here. Okay, now this config here, we have this full parameter list. The very first thing here we want to do, which is super important, this setup. Over here, make sure that orientation is default this one, 0, not something else. And if you do something else, it could flip the drone, which you don't want. Okay, so that's one thing that you really have to make sure this is correct. All right, and then we have to go to this barometer settings. Make sure that this barometer ground temperature is 25 degree. Yeah, make sure that one. And then over here, this barometer 1. Make sure that ground pressure is around this, a little over, I think it is 10,000. Okay, so make sure it is this value, okay, or more than that actually. So it has to be around this. Okay, if it is not, just you can have 1, and after that 5 zeros, you're good to go. And then we need to come to another important setting, which is beginner friendly settings, which is this one, the pilot section. Okay, now in the pilot section we need to make sure this default value is acceleration Z, which I think it's the Z value, so we have to set it to 60, and then speed when it goes up, when it goes down. This could be as low as 50 possible. These are very good values for beginners. Make sure that you go ahead and do that. And then here you should also set this pilot Y rate, okay, so to 90. Now with this, the drone will start to fly slowly. It goes up slowly, it'll land slowly. Okay, so you have to make sure you have these values. If you set them higher for beginners, they could cause a lot of problems. Okay, so these are the few things that you need to set before you start to fly. Okay, anyway, so after changing these values, because I have already changed them, so they may look different on your side, but go ahead and click them and change. Okay, just double click and you'll be able to change them. Okay, so as you do that, go ahead and write the params. Okay, and you are good to go. Okay, all right. So we're gonna see you in next tutorial.
Now we're gonna go ahead and try our pause hold mode. Make sure that your battery is connected and make sure that your hardware safety switch is on. And then you should also make sure that your transmitter is connected. So I'm here, and right now make sure that this one, okay, this one is in the middle position. Okay, this is, you should just push it to the middle. Okay, you have to do that. Now once you do that, you should wait for the green light. As you can see that the green light is blinking. If it does, that means that we are connected with our satellites. And then it also means that if it blinks faster, that means that it's connected with more satellites. Okay, the faster it blinks, the better it is. Okay, so as you try pause hold outside, you should wait for GPS signal, which means that our Pixhawk, this GPS module, they all should be well connected to the GPS up above in the sky. Okay, then we'll have better connection and better pause hold, which means that we'll be able to stock in the sky. All right, let's go ahead and try the flying part now. So this is my current setup over here. So the transmitter is on, and I'm gonna push it to the middle over here. As you can see that I'm gonna do it, and after that I'm going to make sure that I'm going to push it to the right side, and this way the vehicle would be armed. Okay, and it would start to rotate. And then over here I'm going to go ahead and push it to the middle and higher, and then this is the time I'll see that the drone starts to flip, not flip, sorry, it starts to rise, and then I'm going to push it to the middle over here, because this is the height that I'm comfortable with. Okay, so our drone is flying, and then I'm going to push it
the pitch one, I'm gonna push it to forward, so the drone is going forward, and the roll pitch to the right. Okay, so the drone is moving to the right, sorry, left, and then the roll is going to the right, it's gonna go to the right. Okay, now it's very stable. As you can see, that is extremely stable. Okay, and this is possible with this pause hold mode. Okay, now if you want to land the drone, all you need to do, push it down just like this, push it down, and it's going to auto land. And this is amazing, as you can see that. Okay, so this is where it's landed, and if it's landed, all you need to do, just push this to the right side. Okay, and it would auto disarm. Now it has disarmed. Okay, so here we are going to do a test. So this is the nose, and this is the heading direction of the GPS module. Okay, make sure that they align. Now they would be facing toward that, and I would be standing behind. So in general, when you fly a drone, it should facing forward and you should be in the back. Okay, and then we're going to control the drone. Now one basic theory, so if it starts to fly, if it moves away like this, okay, so we'll put or we'll push the right stick to the left. So because you want to move it to the left, right? So when it goes to the left too much, and if you want to move it to the right, you'll push the right stick to the right. Okay, so let me tell you. So it'd be like this direction. So this is our right stick, right? So if we want to move it to the right, move it, gently push this one, move it to the left, gently push this one, and diagonal direction, forward, right, like this, backward, left, like this. Okay, you understand? All right, and this one is simply just for our currently throttle stick. So here you'll see we're gonna go up, gently go up like this. Okay, that's enough. Okay, because we are going to do a stable, pretty much stable altitude practice. So that's what you have to know. Okay, so now our drone is ready. Okay, so we are going to switch on this hardware safety button. Okay, so now it stopped flashing and stopped beeping. So we are going to be ready. Now here we are waiting for a blue light. The blue light is on, so that means we are ready to arm. Okay, now to arm, over here we're gonna push it to the left side. Okay, okay, so we do this and the vehicle would arm right away. Okay, now one of the motors is not spinning because the motor, the one that I'm using, not very good, but you can ignore that.
没有那边光线好。
So now here's a drone that's flying. Okay, so now I'm trying to maintain stable altitude. You can see that. You see it, okay. Now it's not stable on its own. The reason is one of the motor. 你靠近我，我在讲话。你旁边我旁边就可以了。就这里。Okay. So the reason is it's moving left and right. One of the motor that I told you is not good. So it's a better hardware choice. Okay. So now we have a very strong wind over here, and we're able to maintain it. Okay. Right. Now we just had a very strong wind, and for the purpose of training, I just landed. But in general, we can still continue. So let's continue. I'm going to practice one more time here. So here's my throttle stick. As you can see, that throttle stick, and I'm going to push it to the right so the vehicle would arm. Okay, we are waiting for one more time. Okay, now it has armed. Okay, so now let's go ahead and try to spin it. Okay, so here we are. Okay, let's move it to the right. Now, if you're a beginner, this should be the process to start flying. because you don't want to go so high, because this way you may crash your vehicle. Okay, so you don't want to do that. So you just want to practice forward and backward, left and right. So that's what you want to do. So as you can see, that's what I'm doing right away. So right now I put it to the altitude hold mode. Okay, so it's trying to hold the altitude, but it might not work that well. Okay, so the hardware could be a problem. All right, but it's trying its best to put it in altitude hold mode, as you can see over here. But anyway, now I'm gonna move the drone to the left side. Now I'm gonna move the drone to the forward, and then backward, and then to my right, as you can see that. Okay, right. Now I'm gonna put land button over here, so it's gonna land automatically, okay? And it land very nicely, better than me.
Okay, so if you have followed so far and built this drone along with me, so you have done an amazing job. And I would say that you have almost mastered the basics. For me, when I was doing this thing on my own, it took me months, but you have just done it with 2 hours course. It could have been maybe taken a few weeks for you, but still, it's a big achievement. Okay, this basic drone paved the layout for your life if you want to be a robotics engineer or drone engineer. But this drone is still limited. It can fly, it can come back, it can do some fun stuff, it can rotate, it can do loiter, a different kind of fly mode. No problem, it's great for fun. Next, you want to build this drone with me. And what's the beauty of this drone? Actually, it's carrying a Raspberry Pi. It's carrying a little computer with this. And with this, actually, you'd be able to do much more advanced stuff, as I was talking about delivery, surveillance, taking photographs, shooting videos, and tons of AI stuff. With this drone, if you would want to do this drone, build this drone and do this course with me, you'd be doing a lot of AI stuff with me. Okay, so it would learn, it would do automatic obstacle avoidance. Now, to learn more about this drone, definitely you should check out the link below. Over there, I have a lot of information about this advanced drone, which could be used for a commercial purpose. So let's continue to learn drone building. Thank you.